Welcome. Today we'll find all zeros, both real and complex, of the polynomial x to the sixth power minus 1. Let's solve this step by step. First, let's recognize that this is a difference of sixth powers. We can factor this as x squared minus 1 times x to the fourth plus x squared plus 1. Let's solve each factor separately. 4x squared minus 1 equals 0. We can factor further to get x plus 1 times x minus 1 equals 0. From this first factor, we get our first two zeros, x equals positive 1 and x equals negative 1. These are our real zeros. Now for the second factor, x to the fourth plus x squared plus 1 equals 0. This is a more challenging equation to solve. These will give us our complex zeros. To solve this, let's make a substitution. Let's let u equal x squared. Then our equation becomes u squared plus u plus 1 equals 0. This is a quadratic equation. We can solve it using the quadratic formula. U equals negative 1 plus or minus the square root of 1 minus 4 times 1, all over 2. Simplifying under the square root, we get negative 1 plus or minus square root of negative 3, all over 2. Now, remember that u equals x squared. So x equals plus or minus the square root of negative 1 plus or minus I times root 3 over 2. Let's visualize all 6 zeros on the complex plane. The two real zeros, positive 1 and negative 1, lie on the real axis. The 4 complex zeros form a hexagonal pattern with the real zeros. In summary, we found all 6 zeros of x to the sixth power minus 1, 2 real zeros x equals plus or minus 1, and 4 complex zeros that form a hexagonal pattern in the complex plane.